Okay, in this second video, I want to look at a first order linear differential equations problem where we're trying to get the particular solution, which means that we have some initial conditions. All right, so we have x squared y prime plus xy equals 1, and our initial conditions look like this. X is to be positive, and y is 2 when x is 1. All right. So we need to put it into the form that we talked about. Let's go back and look at that form. Here's the standard form here. So you want your first derivative plus some continuous function of x, which we call p of xy, equals some continuous function of x, which we call q of x. So we need to put it in that form. All right. So let's move back to our problem here. So here we do have the first derivative in the first term. Let me make this bigger. There we go. We have the y term here, and we have, something on the right-hand side. So we need to get rid of the x squared, or actually, let's multiply both sides of the equation by 1 over x squared. So if we multiply by 1 over x squared, we end up with, in this first term, dy dx. X times 1 over x squared gives us 1 over xy, so plus 1 over xy, and 1 divided by, or 1 multiplied by 1 over x squared, or 1 divided by x squared, it's the same thing, is 1 over x squared. All right. So now when we have it in this form, we can identify p of x, which is 1 over x, q of x, which is 1 over x squared, and then we form our integrating factor. So I of x is equal to e to the integral of 1 over x dx. And 1 over x, again, is what p of x is. All right? So I of x is equal to e to the integral of p of x dx. And we just replace p of x with 1 over x. So that'll be equal to, when we integrate 1 over x, we get the natural log of the absolute value of x. So I of x is equal to e to the natural log of the absolute value of x. Well, e to the natural log of x, these are inverse functions, which just leave us with the absolute value of x. However, since we know up here that x has to be positive, we can drop the absolute value. I of x is just going to be x. All right, so now our general solution, and that comes from, let me go back to what we had right here. The general solution is y is equal to 1 over the integrating factor I of x, integral of q of x, I of x, dx. All right. So y equals 1 over x, 1 over, there's the x, integral of q of x, which is 1 over x squared, I of x, which is x, dx. So after the integral sign, we just end up with 1 over x. So I have 1 over x, integral of 1 over x dx. So 1 over x, natural log of x plus c. And we go ahead and try to figure out what c is, since we do have some initial conditions. We're going to use that y is equal to 2 when x is 1. So I put in 2 for y, 1 for x. I know the natural log of 1 is 0. So I get 2 is equal to 1 times 0 plus c, or c. So c must be 2. Our constant of integration must be 2. And so now we plug that into here, and it enables us to go from the general solution to the particular solution. So y equals 1 over x times parenthesis natural log of x plus 2, or if you want to just form a single fraction, you can. Y is equal to the natural log of x plus 2, all of that divided by x. All right, and that is your particular solution.